A closer look at the different classes: SSIM, MS SSIM. Okay. Learnings SSIM and MS SSIM. Here SSIM 9 equal to 0.9800. Here SSIM 1 equal to 0.4386. Higher sensitivity to errors in textureless regions. Multiscale is helpful when dealing with the transition regions. Learnings: a closer look at the different losses. Clean. A closer look at the different losses. Clean, noisy, clean, noisy, L2, L1, SSIM, MS, SSIM, mix. Results: why mixing MS, SSIM, MS, SSIM and L1. Clean, MS, SSIM, MS, SSIM plus L1. Conclusions: what have we learned? Even a shallow network can produce state-of-the-art results. If you train it carefully, perceptually motivated loss function can help. Perceptually motivated loss functions can help. But we have to be aware of their limitations. Image restoration is an important and widely studied problem in computer vision and image processing. It is a classical signal processing problem with application in diverse domains such as biology, physics, and entertainment. Various image filtering strategies have been effective, but invariably make strong assumptions about the properties of the signal and or degradation. Plug and play PNP regularization. The knowledge of the forward model is combined with a powerful denier to obtain state-of-the-art image reconstructions in order to image a distant object through atmospheric turbulence. It is necessary to correct for the phase errors that would otherwise cause remedially varying spatial blur in a conventionally focused image. The aim is to the plug-and-play framework, which is based on ADMM, Alternative Direction Method of Multipliers. ADMM is a popular method to decouple the log likelihood and the log prior probability terms in the MBIR model-based iterative reconstruction cost function. The task was formulated as a regularized inverse problem that was subsequently transformed into an iterative form by relying on the ADMM and plug-and-play framework. Low-rank tensor optimization with non-local plug-and-play regularizers for snapshot compressive imaging. Here, this method is using tensor-based degradation model, proposed GNLR model, and algorithm model alternating direction method of multipliers ADMM, alternating direction method of multipliers algorithm for solving GNLR, hyperspectral image reconstruction, PNP, snapshot compressive imaging, SCI, three-directional tensor nuclear norm 3D TNN. Results: the proposed method achieved around 4 dB improvement of the MPSNR value when mu 10 to 5 MPSNR, that is the proposed method achieves around 4 dB improvement of the MPSNR when mu is 10 to 5 MPSNR 29.283 dB to when mu is 0.1 MPSNR 29 to 85 dB. The larger MPSNR value, the larger MSSIM value and the smaller SIM value mean a better reconstructed result. The 3D NN NGMET GNLR MPSNR are according to 27.26 dB and then 27.21 dB, 29.33 dB. For this MPSNR, the proposed method achieves around 4 dB improvement of the MPSNR. Okay. So here in deep red unfolding network for image restoration, deep unfolding new network deep red denoiser DRED CNN based prediction of alpha k beta k synthetic images with AWGN raw images with real noise, real world image de-blurring, single image is super resolution SISR, plug and play deep convolutional neural network, deep unfolding neural network, de-blurring results for house with 65 cross 65 motion blur kernel and mu sigma equal to 2.5, noisy blurred images 15.76 dB, EBLL 27 dB, C IDD BM3D 26.67 dB, DIRCNN 27.23 dB, DVIR 27.56 dB, DVDNN 27.30 dB, USRNet 28.63 dB, DWDN 27.16 dB, DRED 28.81 dB, de-blurring result for Barbara image with 23 cross motion blur kernel and sigma 7.65, noisy blurred image 20.01 dB, EVLL 24.52 dB, IDD PM3D 25.4 dB, IRCNN 28.01 dB, TPIR 29.19 dB, TPDNN 28.11 dB, RGDN 28.59 dB, WebNet 28.0 dB, USRNet 29.36 dB, TWDN 29.0 dB, TRED DUN 29.52 dB. And then on plug and play regularization using linear denoisers. Here PNP algorithm, kernel denoisers, PNP using symmetric denoisers, linear denoisers as scaled proximal maps, scaled PNP algorithm. Here result restored images obtained using scaled PNP ADMM, SN, SPNP ADMM and standard PNP ADMM respectively. Rho equal to 1 in both cases. The respective BSNR with respect to the ground network images are 29.04 dB and 27.98 dB. Scaled PNP ADMM using NLM denoiser standard PNP ADMM with TV denoiser, standard PNP ADMM with DNN denoiser. The PSNRs are 29.04 dB, 27.87 dB and 30 dB restored images obtained using scaled PNP FISTA, PNP FISTA and standard PNP FISTA respectively. The respect PSNRs with respect to the ground truth images are 31.28 dB and 31.15 dB. Fixed point and objective convergence of plug-and-play algorithms, image reconstruction, proximal operator, averaged operator, regularization, linear denoiser, convergence, PNP algorithms. Image super resolution for k equal to 2 and sigma equal to 10 using PNP star. The observed image has size 256 into 256 scaled for display purpose, whereas the other images have size 5112 cross 5112. The third and fourth images are the reconstruction from PNP II star. The respective SSIM values are 0.728 and 0.747, while the PSNR values are PSNR equal to 27.72 dB and 28.01 dB. Coherent plug-and-play digital holographic imaging through atmospheric turbulence using model-based iterative reconstruction and convolutional neural networks. Digital holographic (TH), model-based iterative reconstruction (MPIR), TH-MPIR algorithm, coherent plug-and-play CPNP, convolutional neural network. CPNP improves image quality by a factor of 2.2 cross and phase error correction by factor of 2.9x on average. Generated test data with SNR equal to 20, 10, 5, 2 and DRO equal to 0, 5, 10, 15 for each of the 10 images. 4 cross 4 cross 10 equal to 160 total realization. Block coordinate regularization system. Block coordinate regularization by denoising. Plug-and-play periods PNP and regularization by denoising RED. Regularized image reconstruction. Plug-and-play periods regularized by denoising proximal optimization. BC-RED as a coordinate descent extension set to the current family of RED algorithms and theoretically analyzed its convergence. The averaged SNR values obtained 27.64 dB to 28.12 dB for padding 0px to 40px pixel by PC-RED for the random matrix with 40 dB noise and patch-wise residual CNN, and an online plug-and-play algorithm for regularized image reconstruction. Regularized image reconstruction, plug-and-play periods regularization by denoising, iterative thresholding, alternative minimization, stochastic optimization. PNP SPGM. PNP SPGM is close to that of the batch algorithm with the final SNR for B equal to 10 and B equal to 30 being within 0.2 dB and 0.01 dB respectively from that of PNP APGM. Additionally, PNP SPGM achieves a significant speed up due to the reduction in pre-iteration complexity. Performance analysis of plug-and-play ADMM, a graph signal processing perspective. Plug-and-play ADMM concerns equilibrium